to do a project starter. I want to start getting you prepared for that, for this module. And we're going to start at the beginning. We're going to start at the beginning, and I'm going to walk you through some of the basics and a little bit about what kind of UML I'm expecting. And then we'll throw out some skeleton code and test it. I'm going to get it up to probably adding to a linked list the base class that's going to be totally abstract within the scenario, and we're going to use dynamic binding. So we got to determine where should dynamic binding be used. And it may not make sense in the scenario, but I want you to demonstrate that you're able to do it. So we're going to build a abstract class with a contract and implement the overridden virtual functions, and we'll see where it goes in the design. A lot of this I'm going to be doing on the fly, guys, where you're going to have a little bit more upfront planning and documentation. I'm not going to flesh it out a lot. The goal is to give you a little bit of a skeleton and some direction. So that's what we're going to do for this module. We're going to start that. Let's begin. All right, the first thing to do is probably a UML diagram. So we'll talk about UML diagram as I set up a project. We'll see here. Actually, yeah, UML diagram. Let's just do that. And I'm going to throw in a search for UML diagram examples and give you a little narrative on what I think about them and how well they are. This one I like this. I like how it's laid out here with the different types of classes. I like when in the header, if it's an abstract, that somehow it's in this header. So this is the type of diagram I'm actually looking for. Nothing more complex than this. And then, yeah, that's great that this popped right up. So let's go look at this one. This one's good. Huh? Okay. I didn't want to get that far into it. That's fine. Okay. We'll do it the hard way. You silly goose. Let's get in there. Save image as whatever. Yeah, fine. Be that way. This one's a good one. This is not bad. But you see how they're using different criteria here for how the lines are drawn. See, there's a diamond here, but aggregation. What I'm looking for is mainly for you to label which one is abstract. Yeah, but everything else is great here. Now we can use a key for deciding how we want, these arrows to be drawn. And actually, that's a good idea. Yes, I'm gonna have that for you. So, other ones. Let's look at some other ones. This one, I like. Again, this one's rather simple. If there was an abstract class, I would want abstract either below person, whatever is the abstract class that's going to be doing the dynamic binding, I would want clearly labeled. Because that's the contract, that's the blueprint for the whole library. And once you stem from that base contract, you have a whole technology. That's how C# is built and Java is built, is this way. Yeah. But anyways, that's what I'm looking for is and so let's draw it out. I'm gonna have horrible chicken scribbles, and I kind of got a little side kick there with what we were doing, but that's fine. The whole idea is to give you a clear idea what our UML is going to look like, and I'm not going to be fleshing this out totally. I'm just going to lay out a little bit of it. I'm not going to even flesh out the linked list portion of it. But here's going to be the scenario that I'm going to be modeling. And what it is that's a little closer to what we got. The system, we're going to develop a management system and utilize an abstract base class with dynamic binding of somehow demonstrate it. And we're going to store patients, and there's going to be different derived patients of the patient system. And we're going to have the ability to have persisted binary saving and loading for those patients. Now, here's where the issue is with binary saving and loading and design is every patient on the list, an outpatient and an inpatient and an emergency patient, are all going to be different sized. So a binary file is going to be a little bit on the difficult side, and it's going to need either a header that describes what types are in the system and where they're at, or in the file and where they're at in the file and the size of them, so that it's a description of what patients are in the file. And that's fairly complex, but totally possible. Or you can do it like a database does it and have a separate list for each data type: outpatient, inpatient, and emergency. Save that as binary. Let's go with the flow. Let's go. We can do it both ways. I'm gonna start with, I believe, the more difficult one. The one where they're all in the same file, and demonstrate how to do a header. And I think that's going to be more beneficial, you know, in the context of the project for you. So we're going to do that. Let's see what else. Let's get started. Whiteboard. Patience. And remember, I'm not going to fully flesh this out, but we're gonna have patience, and patients are going to. Oh yeah, that's horrible. Patients are going to be abstract, so you would label your abstract here. Okay, you silly thing. My art is so horrible. It drives me insane. Let's start this over. Let's go with this. All right, patience, and then we would have something like, what I would like is you would put either abstract here, clearly label that it's abstract. Okay, just pretend that I've drawn abstract there. Okay, or just type in abstract up here. Okay, I'm done. That's enough. I've shown you the examples, and that's what I'm looking for. And then the next thing is I'm going to give you a key for how you're going to draw the arrows to your derived classes. And there's going to be different ways that the arrows need to go that determine what kind of a relationship it has, because when we are going from a base class to a derived class, we're getting more specific. So the derived class that would inherit from patients in our scenario there's three of them: outpatient, inpatient, and emergency. So this guy would be outpatient. Okay, now let's look at the key for how it would go, and excuse the primitive drawings, and we are ready to move on. All right, so yeah, there's different ways of doing the arrows for your relationships. You'll mostly be using the generalization, that's it, then your inheritance, and then composition, aggregation. So there is a link available for you to read. I'm thinking this is gonna be the one ring of truth on what it is: generalization, that arrow; inheritance, composition, the arrow on the left; and then if your composition is more aggregation, of course, the arrow on the bottom left. And just try to follow those guidelines, and also, if you have your own convention, I'm totally cool with that. Just throw in the convention, whatever it is. Give me a key for it if you decide on a different one. That's the main thing I'm looking for, is that you've got something that has a little bit more of a graphical representation of what's going on, because when design happens at that level, there's people that get involved in the project that don't have the ability to follow along with the code. It's hard to visualize, and also it's a great tool to use to get started on actually working with it. So let's. I'm ready to get into the meat of stuff. I really want to show you the. I don't want to show you too much of this stuff right here. I want to get into. Let's start writing some code. So I've got some example code, or not some example code, but I've got code that we're going to be using that was developed from stuff that we've done through the videos. So, well, give me a second to deal with this. Jeez. All right, we're doing it from ground up. Create a new project. I'm using 2019 here. You can use a newer version, of course. This one I kind of like, yeah. Console, empty project, the usual. C++, good. And I want it to be on the desktop. I'm going to select folder, and this is going to be patient manager. And I hate uppercase, so I like to use snake. I like to use snake style. So let's do patient manager, and let's go like that. All right. Good. Nice. Great. Now, first thing, I'm going to throw in the scenario into this project. And I'm going to get some code, and this is from the other videos, and I'm also going to provide it so you can grab everything that I am going to use from previous stuff. So I'm going to throw this inside of the project. Now let's throw it on this BC. Heck with it. come back to that. We got too much to do. I'll get it in there. All right, header files. We're going to need an abstract, a true virtual abstract patient. So the way that code's going to look is we're going to start it out with, we're going to have functions that are going to be virtual for the dynamic binding, at least one. We're going to implement at least one somehow. And I'm not, it may not make sense, this example, so we'll see how it goes. So the actual code, let's see. So let's flesh it out. We're going to start with pragma once and a file called patient, patient.h. New item. Header file. And call it patient. This is going to be our abstract, our base class. That's going to have virtual functions in it. Okay, and we're not going to get too lusty on this for stuff, but we need at least a string, and I've got some preparation notes over to the side here I'm using, of course. And let's see, string class patient, and let's see right there. Now I don't like this stuff right there. All right, let's get a basic constructor. And a basic deconstructor. And we're not gonna, again, get too crazy. I'm just gonna throw these guys in here, and we may need them as we progress. Okay, now these are gonna be public. So I'm gonna do public below and then private above. I like it that way just because private is usually short. You know, there's not as much code for private code. Now, what kind of data we're going to need and have to protect? Okay, I'm going to demonstrate this with a number and I want, because this is going to binary, so this cannot be a C string, so we got to do that conversion thing. And I'll find that code and implement it here as well. So let's write out what we need. We need a name, and that's going to be a string. Let's use using namespace. Okay, and then private. We need an ID. Int ID, easy. String char name, and you guys are going to have first name, last name, and I'm going to allow it to have 100 characters. And that's going to be to make it easier to save it as binary. Now, of course, if you're going to implement serialization, that's a way that you can get around the string stuff, but serialization is a bit of a heavy lift, and let's stick with something that's not so crazy. So yeah, with all that stuff, well, it's not that actually bad. Serialization, once you got it set up, is actually pretty cool and simple. We'll see if we We'll see how far we do on the binary. All right, we got name. Okay, now we're just going to need the simple get ID, set ID, and that's going to be a integer return get ID, and we can return this one, return ID, and then int set ID, and I'm going to make this user. The set ID, I'm going to not filter, but I'm going to take the current, the ID of this instance instance and assign it to the ID that's coming in through the function. And good, and that's for ID. Now this is going to be fun, because we're going to have the conversion so that we can work with strings outside of the class. I don't want to have to work with C strings unless it's at that lower level where I have to. Yeah, I would rather work with strings. They're much nicer, but we're not doing serialization. So, all right, next, let's copy that in. This is going to be get name. And this is going to be set name. And this is going to be a string. And we're going to have that conversion where we're going to say that the name, and we're going to find that here. I'm going to find the conversion here. Get name, return name. Okay, simple stuff. This is and we're fleshing it out about as far as we've gone. Let me open this up a little bit more. I'm sure that's kind of getting to me too. I'm hoping I got it big enough for you so that we can reference it. All right, patient ID, name, get ID, set ID, get name, return name. That's fine. I don't know why it's, oh, right there. Return name. Now that's got to be a string. So we got to do the conversion again to get name. I want to build that. This is a tool as an interface for string in the character array. So you see that we have two errors that we're going to deal with. This one and this one, because we're assigning a char array to a string and vice versa, a string to a char array. All right, so that's the next step. All right, so we need to go from char array to string. So what we can do is we can generate a string on the name using the constructor. Now, I think direct assignment also works. There's an overloaded for it. And we can say here string name, and it's going to be separated from this name, equals this. Oh, that's going to be silly. Okay. What we're going to do is, yeah, actually, let's just, the hell with it. Why even create a variable? Return this name. Actually, I really want to do it with a variable. With it, string str equals. Actually, I have that actually up. Let's bring it up. Yeah, right there. So that's the way it's done, right there. Okay. And then we do this. This name. There we go. I think we could do like use the new with this and really get fancy with it. But I'm gonna put it on the stack. It's really better. I like it much better. Okay. That I think is good. Rebuild it. See what's going on. Oh, duh. I hit Control S and F5 right there. Control S for save, F5 to rebuild it and run. Okay, which is fine. I know this is going to be an error, but this looks good. So now we need to go from string to char array. Oops, before we go from string to char array, let's fix this little oopsie here. Set ID and set name should be void. Okay. And for that, I got some reference code that we're going to use that I pulled up. We need to have some kind of array, which we do have already, and it's this name. And name is coming in here, so we got to do that, and we got a string copy. So we're going to have to use a string copy. We're probably going to need that. We'll see. We'll see how it goes. String copy. This is going to be this name. And then this is the function that converts the string to a C string. And that goes away. So we have all our stuff. The last thing we need is an overloaded constructor so we don't have to do all this silly stuff. And I actually like my constructors up above and my deconstructors, so I'm going to throw those up above. Now that I got a little bit more structure here. Okay, now let's do an overloaded constructor with string name. And oh no, let's do ID first. Int ID, string name. And we're going to say set name, set ID, ID. And that way, if I need to filter these, I only have to filter them in one spot. I only have to filter it here. If I need to add if statements for validation, which actually should be done, we should be adding if statements and looking at this before we actually set it to protect the data. That's proper abstract behavior for your design of the object. Now that gives us a ground. We don't have any dynamic memory here. We have just data and stuff to get at the data and work with it. Okay, so let's just do a full on, so you can kind of get an idea of a full on look of what we got here. Okay, pretty mundane. We haven't really started to spark it up yet, but we're going to spark it up. And I'm going to think about what kind of data would need the security of dynamic binding of a patient. And oh my God, there is so much data we could actually have that should only be modified with dynamic binding and overridden from a base class to a derived class. So what data needs to be protected? And I believe that if you have a patient and an ID and a name, at the very least, the ID of the patient could be more valuable than the name. And we may, if we're going to be using it for setting data, We may even make it so that everything, behaves with dynamic binding. But if we're implementing dynamic binding, it needs to make sense. It needs to follow proper polymorphic design. And that is when you have two like objects that do the same thing, but also differently. So what data would need to be secured? No, maybe what behaviors? Let's think. I'm going to think about that. So back to the scenario. And the more I think about it with a patient system, the most important attributes to protect would be the ID. So let's pretend and make that a virtual and set the ID. And the way the ID is going to be set is we're going to have the person at the front desk that's inputting it, and let's just pretend that that's what's happening. Is somebody is registering or putting a patient into the system, and setting ID is important, and making sure that the ID is set properly. But the ID setting and verification is going to be different for outpatient and inpatient and emergency. Outpatient and inpatient are going to have a little bit more security to it. It's going to have some questions that it's going to ask the user, where it's going to enter in driver's license number for verification that they check their ID. And that's going to be for emergency, that they've checked their ID and they've written down their driver's license number. And so let's lay that out. So how are these polymorphically going to behave differently, and how are we going to implement that with so that we're having security by using virtual functions, and we're allowing for an ID to be set, but the difference is how the ID is set. So for outpatient, no driver's DL lookup. Inpatient, yeah, DL lookup. Because I figure outpatient, they've already got them in. They're kind of a fly through, and again, I'm going with, hey, this is an example of polymorphism. So if it doesn't make sense, don't freak out. It's okay. I'm trying to show you how to implement it within this scenario, and that's what we're doing right now. So the outpatients, when the ID is set, the user of the system who is entering in the ID, when the ID is set, it has to ask and verify that the driver's license has been looked up. So that's immediately going to change our URL, or UML, excuse me, so that we need a Boolean Boolean and inpatient and emergency, and a data piece that is the driver's license number that has been looked up. Okay, let's do it that way. I like that. I like that example of polymorphism, simple, direct, and we're going to implement it with data and set functions that we already have. So it's going to be the job of outpatient, inpatient, and emergency objects to set the ID. And we're going to turn this set ID into a contract. All right, which means it's going to become a pure virtual function. Now I've got some reference code, but I believe we just set it equal to 0. Hello, C++. We might be missing something, but I don't think so. Let's do this. Okay, yeah, we're missing something. All right, I got some reference here. Let's see. Let's try the reference. Let's look at the reference. Set ID. Oh, duh. What am I doing? I'm being silly. I'm being so silly. Thank goodness for references. I love you, references. Okay. That's our contract. And everyone is going to implement it differently. By 2 of them will operate the same, but another one won't. It'll just be a pass-through. So, I think we're at derived class time. Yeah. And then after that, we'll just run a quick driver. And that'll begin our starter. And of course, it'll be multiple times where I come visit you. This won't be the first video on this, I don't think. So, let's get a derived class in. And what's our derived classes? Outpatient, no driver's license lookup. So, outpatient doesn't need a driver's license field. So let's build outpatient first, and then inpatient is going to be a little bit more complex of a set ID. All right, now what we can do is let's just copy this thing, and we're not going to need everything, but we're going to hack and slash, and add. Hack and slash. It doesn't look like we implemented, I did all inline here for this one, guys. I always do it so that when it's time to release, I separate it out for release, not for development. That's just the way I go. So let's do this. This is going to be outpatient. I think that's the one that outpatient. That's the one that we've decided does not need stringent ID protocol checking. Stringent. Okay. There's our pragma once. Let's bring this in. This is going to be outpatient. Outpatient. We got to include. Oh, why did you do that? And include patient.h. Okay. And then outpatient, we don't need any of this. Boom. Let's do this. Control C, Control V. Oh, I can just put out in front of it. Oh well. Good. Don't need that. Don't need any of that. We do need this. We are going to call the base class here. We could use the base. Yeah, let's do it that way. Let's do the. Did I misspell patient? Oh my god. Ah, well, hell with it. I'll fix it. Hold on. Double check. No, I got it right. It's good. Well, there is no set ID. I'm being silly. This is the set ID. And then what we'll do is we'll say this ID, we'll just do a straight up set ID. No filter, no filter. Because this is how outpatient behaves, it's not going to have any extra dimensions to the set ID. I'm not going to filter it. So I'm doing that behavior. The set ID is going to be different for different types of patients. And the hospital industry, I do know that the ID thing is important, especially for like insurance stuff like that. People are always trying to falsify that. Always. So it's a big deal. Let's see. I mean, yeah, if somebody can get in and get, $200,000 of treatment on somebody else's insurance, that happens all the damn time. Especially when people are in that situation. I gotta stop. Okay, let's stop. Let's see if this actually does anything that I want. Let's see. Okay. I would want to test that. I'm going to want to test that. And I'm going to test it very simply here. I think now it's time. Now it's time. Add a new item, and it's going to be a C++ file. And this one's going to be main. Okay. Pound include outpatient dot h. Oh, I messed that up. And then what else is next? Outpatient include string. Most of the other stuff we'll get into the meat here, and let's do it a little bit more Linux friendly. Yeah, we don't need that anymore with the updated stuff. Okay, and then let's see, main. Let's zoom in. All right, that's what I have. We're going to have a patient called Paul, and he's equal to a new outpatient. Now we need to overload and pass through to the base class the name and stuff with the member init list. So this is going to have to change a little bit. Let's go with the member init list. I think we can do it this way. I think that works. I could be wrong. Yeah, okay. Oh, I did it wrong. I'm using the wrong operator. I'm not using the correct one. Okay, still wrong. Okay. Let's see. I'm gonna dig into this. Well, the first problem is I didn't finish my inheritance. Okay, you don't like that, fine. Okay, yeah, all right, that I think that worked. Oh, set ID. That needs to be ID. All right. So what outpatient is doing is it's fulfilling the contract of patient's set ID. And this one is the simple one where we just pass it through without requiring a driver's license number. It kind of is oxymoron because it actually works differently. Emergency is where they just pass it through. Yeah. So remember, I'm not looking for exact perfect making sense. I'm looking for that you know how to do the mechanics. That's it. All right. Let's get into why this is being such a little stinker and not wanting to pass down to the base class with the member init list. Well, actually, this might be time to get into some of the fixes here. This needs to be a more it's yelling at me for that because it's been updated and I should be using the updated one. So string copy underscore s. And then right here, oh, I'm probably doing something wrong. Oh, that's right. That's right. How are we going to do that? Let's see. Now, the next error takes us here. And totally cool because Paul can't, a patient can't be instantiated because it does not have the set ID implemented. It can't be actually used. But a reference to, or a patient reference, that's what's actually being used in dynamic binding. And I'm creating a reference here to the actual memory on the heap that is going to implement the set ID up the call stack when it's looked up, and it does the dynamic reverse binding. And then now right here, I'm also getting an error because I don't believe I set up a default constructor for this. So I'm going to have to put in here Paul, and then his ID is going to be whatever. Let's just do one. It's fine. All right. There we go. We're getting closer. Probably should include patient up here just in case. I probably need it actually because I'm instantiating it. Yeah, that's what was killing some of it. But we got, no, actually it wasn't. I didn't think I needed it. All right. Before we move much further, let's clean up some things. The first thing I need to do is just overlook this and look what I'm doing. I see here patient.h. We're using string copy underscore s now, but that needs C string. Not string. So we need both now. That might fix some stuff later on. So I'm just doing a cleanup. Outpatient, same thing. Let's include C string just in case. Include, and if we don't need one, C string. We can always do it later. Okay. And then main. That's another thing is I look at outpatient and its ID name and patient ID name as well. So that's another mismatch. And I think that might, let's see if that will fix where we're at. Okay. And this one, I think, let's look at it. Oh yeah. My initial instincts were correct. Okay. Okay, we still got problems. Okay, well, hey, that's something. All right, well, I got a skeleton, some errors. I think, let's look at this, because this is where every issue is at. We fixed that. What? That. Is there a set ID in patient? No. It's pure virtual. And then my copy paste. Oh, I remember what I did now. I copy and pasted that directly in. We never implemented it. Oh my God. What a silly mess this is. Okay, well, now we know. Yep, that's the way it goes. I didn't fulfill the contract. Yeah. I mean, the one thing that you have to do when you're inheriting and implementing polymorphic dynamic binding within polymorphic design, I didn't do. Yeah, I'm inheriting from patient. Patient saying, you must inherit set ID or else. Okay. All right, I did it. Quit yelling at me. Quit yelling at me, please, please. Okay. Thank you. No! Linker error. These are the worst ones. Okay, well, let's look at this silly linker error. It says reference this call from patient, and what it's having a problem with is the patient set ID. Let's go to patient. Wait a minute. The patient has no ability to set its ID. It can't do it because it doesn't have it. And when we instantiate patient, it doesn't know ahead of time for dynamic binding to work. So that's a big no-no. In fact, that needs to go away. Patient is incapable of setting its ID. It set a contract for something else to do it for it. So this needs to reflect in the constructor of outpatient, so that now patient only gets the name and the ID is handled by the user. And since this is outpatient, we're just going to filter it right through. It has no security. Oh, but we got to have a special thing here. We got to have a special thing here that says that it's actually being overridden. And if you're working with some kind of management system, multi-threaded, etc., this can get complex. So we have to fix the linker error. It's having a problem with this. Let's see. I'm making sure that this is an override so that linkers can find it. Oh, is it 1 V and 2 R's? Yeah, okay. That might help. Let's see if it gets us closer. Yeah, nice. Boom! We got it. We don't have it fully fleshed out yet. This is going to be just this ID this ID equals ID. This, no, literally ID. Oh, yeah, we got to use the, no, you've got to have protected. We got to change ID to protected because we can't access it here. We have to access it from patient, and it's private. Let's set that to protected. It's going to have a different. It's going to have access from the derived class. So let's see if that gives us the ability to directly set the ID. I think it does. From the derived class, yeah. It gives us the ability to directly set the ID from the derived class. Okay, so that was the last little wrinkle. Just getting through that last bit. Because we had to set this ID to the ID, but we needed access to it because it's defined in patient. So we make it protected so that a derived class can have access to that particular data type so that it can fill out its contract, fulfill the contract. And now we have a beginning. We have a start. Guys, let's print this and call it for this one. All right, let's say Paul dot, let's do this, cout Paul dot get name. No, let's do, get ID to make sure that everything is working. Okay, we said 2. I don't know, just get ID. Okay, should output 1. STD is already set. Good. Run it, test it. 1. All right. All right, guys, that's how to set up your dynamic binding. We're going to make it more complex by applying a linked list to it, a templated linked list as a list, and then implementing the header binary saving of patient. Header-based binary saving on patients. All right, and then we're going to use some code that I'm going to have prepared for you from some other stuff that we've done together in our videos. But for now, peace out. Have a good one. Take care.